Hey y'all, and in this week's lab we'll be going over the oscillation of spring harmonics on a closed body system. And the goal of this lab was to analyze the oscillation period of a spring in harmonic motion on both the x and y axis. And through this you can observe the net forces that alternate as the object completes its motion. What's unique in this lab is that it is not just on one axis, but the body is moving in a circular direction. So you have a multitude of different vector forces that are actually affecting its motion, and this specifically comes from the spring that is creating the oscillation pattern. And it's important to note that the fundamental physics of this comes from the mass at the end of the spring, which is just another spring, but in this case, since it's acting as simply a rigid body, it has no effect on spring forces. And the natural length of the spring is 0.7 meters. And from there, you can tell the compressed or extended length of the spring to create the force. And that's what pushes back of the force in the y direction, which is gravity in this instance. And the time between video frames in this for the tracking software can affect where the data points are placed, therefore accounting for some human error. However, it is not significant enough to greatly alter the results of this. And one of the most important equations in this lab to derive is the period, which is the time it takes for the oscillation period of the body. Here is the given video after I ran it through Tracker software. The spring at the end of it is highlighted in red to mark the Tracker software, and you can see it's creating an ellipse shape, which is the difference of the x and y. And as you can see, the spring is also compressing and extending as time moves forward. And graphically, the change in energy, it follows the laws of natural energy, where kinetic and potential energy are proportional to one another, that add up, and the excess energy is then therefore given to the surroundings. So this is in the GlowScript code, however, and the GlowScript code, which looks like this, is set up for obviously a perfect system where there is not significant net energy lost. However, in the actual experiment, obviously, there will be net energy loss that is transferred to very minimal thermal energy in the air, and there's more air resistance that the GlowScript code does not account for. However, when you run this program, and you select the data that must be ran alongside it, you can see that the spring actually in fact creates the same motion that was created in the video. So at a very slow rate because of the delta y setup, it starts at a wider ellipse, however it tightens because of the natural force that is bringing it in from the spring, and therefore overlaps, and same with the change in energy. Now, going back to the presentation, we can see that the position of y and position of x in time is similar but on different magnitudes. And the greatest reason why it's on different magnitudes is because of the change in units. On Tracker, it is ran in meters. However, in GlowScript, it should be run as centimeters. So the general shape follows alongside of it. However, the magnitudes are not the same. And as stated before, the energy principle is satisfied. And like I said, the actual video that we can refer back to, there is an excess of net energy loss that simply GlowScript can neglect because it does not have to factor in those variables included. And additionally, the major difference between the oscillation on the y-axis and the x-axis can also be best seen in this video, where the time it takes for it to round these two distances, which is the x-axis, and these two distances, which is the y-axis, are different because of the forces acting on it. So on the y-axis, gravity is its major counteracting force, and on the x-axis, it's the angle at which it started. which also has to do with the extension of the spring.